Okay, get this. A teenager, we're talking high school. He uses code he wrote himself and uncovers 1.5 million hidden objects out in space.
It sounds like science fiction almost, but it's the real story of Matteo Paz.
Exactly. And today we're diving into how he did it. You shared these articles detailing his work, using AI, this Caltech program, sifting through just mountains of telescope data.
Right from the NEOWISE telescope, a decade's worth.
So our mission here is to unpack how this was even possible, what it really means for astronomy, and maybe, if this kind of approach could work elsewhere.
Well, first let's talk about the sheer scale, the challenge he faced.
Yeah, the data itself.
NEOWISE gathered something like 200 billion infrared measurements over 10 years.
Billion. Wow.
Yeah, and that adds up to roughly 200 terabytes of data. It's essentially these light curves showing how bright things got, how dim they got over time.
So trying to look at that piece by piece.
Impossible.
Right, just completely impossible for a person.
Absolutely beyond human capacity. Imagine that haystack.
So enter Matteo Paz and his AI model, which he called Varnet.
He was in this PlanetFinder Academy program at Caltech. Crucially, that connected him with Davy Kirkpatrick, an astronomer there.
Ah, the mentorship piece, so important. Giving young talent access to resources, guidance.
Definitely.
Yeah.
And Varnet wasn't just, looking randomly. It was built specifically to find variable objects.
Variable meaning their brightness changes.
Exactly. Big changes. Things like supernovae exploding, young stars just forming, maybe supermassive black holes gobbling stuff up. Those fluctuations tell a story.
Okay, so how does Varnet actually do that? How does it pick those signals out?
Well, it uses a few clever techniques. One is this thing called an improved Fourier transform, or FEFT.
Okay. Fourier transform, that's about breaking down waves, right? Like in sound?
Kinda, yeah.
Yeah.
Think of the light curve, the brightness graph, as a complex wave. The FEFT helps Varnet find the underlying rhythms, any repeating patterns in how the object's light changes.
Gotcha. Picking out the beat.
Then there's wavelet decomposition. That's more about cleaning up the signal.
Ah, noise reduction. Infrared data can be noisy.
It can be, yeah. So wavelets act like really precise filters, helping to isolate the real signal from, instrumental glitches or background fuzz, makes the important stuff stand out.
Okay, so you clean the data, find the patterns, then what?
Then comes the deep learning part, neural networks.
Right, the AI brain.
Exactly. You train these networks on tons of examples of known variable objects. They learn to recognize the different signatures, the characteristics in the light curves that say, hey, this is probably a supernova, or this looks like a forming star.
So it learns by example, like teaching it different bird songs.
That's a good analogy, yeah. And the speed is key here.
How fast are we talking?
Varnet, running on GPUs, those powerful graphics processors can analyze one light curve in less than a millisecond.
Whoa, less than a millisecond per object.
Yep. That's what made scanning the entire 200 terabyte NEOWISE catalog actually feasible. You couldn't do it otherwise.
Okay, so the result of all this. What did Varnet actually find?
Get ready for this. It identified 1.9 million potential variable objects.
1.9 million.
And of those, 1.5 million were new. Previously unknown, uncatalogued.
1.5 million. New discoveries. Just like that.
Just like that. It's a staggering number. It massively increases what we know is out there.
And these aren't just dots, right? They represent real astrophysical things happening.
Absolutely. A whole diverse range of phenomena. This new catalog, they're planning to publish it fully in 2025. It's going to be a treasure trove for astronomers.
A foundation for future research, maybe helping with big questions like how the universe is expanding.
Potentially, yes. Having more data points, especially on certain types of variable objects used as standard candles, could refine those measurements. It's huge.
What blows my mind, too, is that Matteo apparently refined this whole model in just 6 weeks.
I know, right? 6 weeks. It's incredible.
How does that even happen?
Well, several things probably came together. That intensive program at Caltech, for one, being immersed in that environment.
And the mentorship you mentioned, Davy Kirkpatrick.
Crucial. Having an expert guide you on the science, the data specifics, that accelerates things massively.
Makes sense.
Plus, Matteo's approach sounds very methodical. He didn't just jump into the deep end with all 200 terabytes.
Right. Start small.
Exactly. Started with smaller samples, built the algorithms, tested, refined, scaled up. An iterative process.
And using those GPUs for speed?
Yep. Fast computation allows for rapid iteration. Test an idea, see results quickly, adjust, test again. That cycle, combined with the collaboration with his mentor, That's how you get a 6-week sprint like that.
It's a great combination of factors. And he sees this going beyond just stars and galaxies, right?
He does. He thinks the core idea of finding patterns in time series data could apply elsewhere.
Like where?
Well, maybe financial markets, looking for cycles in stock charts, or atmospheric science, analyzing pollution data over time, seasonal changes.
Okay. Anywhere you have data that changes over time.
Pretty much. The underlying math and pattern recognition could be adapted.
Which is often how science works, right? A tool built for one thing finds uses elsewhere.
Absolutely. And his work got some serious recognition. He won the big one, the Regeneron Science Talent Search for 2025.
Wow. That's the top prize.
Top prize, $250,000. It's a huge deal in the U.S. for young scientists.
Well deserved, clearly. Is he still working on it?
Yeah. He's actually working at Caltech now, refining the model further. And apparently he's even mentoring other students now, too.
Paying it forward already. That's fantastic. And his mentor, Kirkpatrick, was inspired by his own path, too.
Yeah, the articles mention that Kirkpatrick saw parallels with his own early career, underlining that whole cycle of mentorship.
It really is a powerful story. So we looked at these sources showing how, this young mind powered by AI, guided by expertise, just unlocked this massive cosmic data set.
Pulling 1.5 million secrets out of data we already had but couldn't properly analyze before.
Right. It really makes you wonder, what else is hiding in plain sight in all the data we collect? In medicine, climate science, you name it, what could fresh eyes and new tools uncover? What does this make you think about looking ahead?
It just highlights the potential sitting in existing archives. We generate so much data. Maybe the next big breakthroughs aren't just from new experiments, but from smarter ways of looking at what we've already gathered.
Applying AI, like Matteo did, could be key across so many fields.
A really exciting thought. This has been a deep dive.
Always great to explore these developments.
For more in-depth explorations like this one, definitely check out Lou Podcast de Philippe. And hey, if you happen to be watching us over on YouTube, we'd really appreciate your help. We're trying to hit 1,000 subscribers today, so a quick click would be amazing.
Every bit helps.